Hello, welcome again to Thermodynamics. And the next topic in the chapter of first law of thermodynamics is pre-expansion. So here, to understand pre-expansion, we will take this figure. Here there are two vessels, vessel 1 and vessel 2. They are separated by this wall, and the vessel 1 is filled with gas and vessel 2 is empty. So when and we are considering this as a volume. Okay. So here, when the valve is open, the gas rushes into vessel 2, and this is your volume now, and mass is same because no extra gas is supplied to this these two vessels. This gas has just into this vessel. So specific volume will increase because initially the gas was occupying this volume. Now gas will occupy this volume. Okay. But we are considering this as a system. So as there is no displacement of this system, simply the gas has just from 1 to 2, so there is no work done. Volume will remain same, but specific volume will increase. Okay. So there is no work done, specific volume will increase, volume will remain same, and we are not supplying any heat. So now we will apply first law of thermodynamics. So that is Q is equal to U2 minus U1 plus W. There is no work done, no heat transfer, so U2 minus U1 is equal to 0. So U2 is equal to U1. And CVT2 is equal to CVT1, or T2 is equal to T. So it means temperature remains constant. Initial temperature is equal to final temperature. T2 is equal to T. So as temperature is constant and the gas is ideal gas, so PV is equal to constant. So V is specific volume. So as specific volume increases, so pressure will decrease. Okay. So this is the main fact or main fundamentals of pre-expansion. So reading out the pre-expansion, first point, consider two vessels 1 and 2 interconnected by a short pipe with a valve A and perfectly thermally insulated. So this is your valve A and this is it perfectly thermally insulated. It means there is no heat rejected, no heat received. Initially, let the vessel 1 be filled with a fluid at a certain pressure and 2 is completely evaporated. So this is filled with a gas. This part is here and this part is filled with the gas, and this is empty or completely evaporated. When the valve A is opened, the fluid in one will expand readily to fill both vessels 1 and 2. The pressure finally will be lower than the initial pressure in vessel 1. This is known as free or unrestricted expansion. Next point, the process is highly irreversible because after closing the valve, the gas cannot rush to fill vessel 1. Okay. That's why the process is not reversible, it is highly irreversible. Now applying first law of thermodynamics or non-flow energy equation between initial and final state, Q is equal to U2 minus U1 plus U2. So in this process no work is done because we are not supplying any work and the total volume remains same. Done on or by the fluid, since the boundary of the system does not move. W is 0. We are considering this as a whole system and system remains here, so no work is done. W is 0. No heat flows to or from the fluid since system is well insulated. Q is equal to 0. The process is therefore adiabatic but irreversible. So W0, Q0, U2 minus U1 is equal to 0, so V2 is equal to V1. So for perfect gas, use CVT. So from this, CVT2 is equal to CVT1 and CV is constant. So T2 is equal to T1. As T2 is equal to T1, so PV is constant. So as volume increases, specific volume increases, pressure will decrease due to expansion. That's why it is called expansion. Pressure will decrease. No heat supplied, no work done, but pressure will decrease and specific volume will increase. That's why it is free expansion.